Hello, everyone. So we are going to start soon for the final presentation. So before that, several announcements. Here's the order of the presentation today. So first group will be the ShopBot, the group number one. The near nearby her, the Arvin, Tanya, and Sarah should be ready. And then the other teams, the like number group number two should be ready during the question and answer of the group number one, and the group number three should be ready during the question and answer of the previous team, and so on. Then we can save the time during the transition. Okay, so and also before we start, here are several important announcements. First, the you should submit any missing document, including today's the presentation file and the final writing up to the Canvas by the April 26th. I'm going to wait for your submission by the April 26th. Then we'll contact your advisor on April 27th. If your team need extra time, please contact me before the April 26th, so I can give the extra time to extension of your submission. Then second thing is you should return your item, project item to the department. So I'm going to allocate my office hour April 28th, Wednesday, 2 to 4 p.m. At my office. So you can come to the engineering building and find my office, which is 156. But if you cannot access the engineering building, so you can email me or send a Canvas message, then I'm going to pick up your item in front of the engineering building. Okay, so please if you are not available at the time, so please contact me. Then we can set up the different time schedule to pick up your item. Then I already sent the exit survey, the link. There are two exit survey. One is the senior exit survey. Another one is the senior project exit survey, which are required for your the final grade. So if you do not submit it, you will not get the final grade. So please complete your exit survey. I'm going to share the link during your presentation. Then you are able to complete your exit survey. Okay, these are the thing, and I think that it's almost a time. Okay, officially let's start the presentation. So why don't group number one, why don't you share your screen? And meanwhile, I'm going to the very simple the kick off the present the announcement. Throughout the two long semester, you guys did a great job, especially during the pandemic. So I fully understand how much difficult to do such a group project with your partner. I really appreciate all of your cooperation and hard work. So today is the time to finalize your the work last year. Okay, so please do your best. And even though something wrong, you don't have to the shame or the anything. So I think that you already did a great job, and let's do it. Okay, so room number one, are you guys ready?
Yeah.
Okay, you guys can start when you are ready.
Hello everyone, we are group number one and our project is the ShopBot. Now my teammates will introduce themselves.
Hey guys, I'm Irvin.
Hi, I'm Tony Rodswell.
Hi, I'm Nearby.
And I'm Sarah.
So 2022 was a very difficult year for the whole world, and one of the major daily life problems that people were facing was buying grocery. Until now, people are still afraid to go out and buy their groceries. So to make their lives easier, we have come out with a cheap and effective alternative, and this is the ShopBot.
So all this led us into developing a system that would prevent the spread of COVID-19 by providing customers with 100% contactless services where even the store workers don't have to have any input, and also to just accommodate the new work from home culture that we expect to expand even post COVID, as well as the need for shopping efficiency when people can just shop everything they need through their phone screen, and also uh, easily navigate stores that have long aisles or complicated aisles.
To meet these objectives, ShopBot possesses the following major features: a compact and balanced design, a robotic arm, a shopping cart attached to the base, path detection as well as color detection, and a shopping web application. So these features are achieved utilizing the following hardware components. In the top middle of your screen, you'll see the robot base. Below that, you'll see the line detection sensor. To the right of the line detection sensor, you'll see the color sensor. And both the line and color sensors are attached to the underside of the robotic base. Above the color sensor on the top right of your screen, you'll see the robotic arm. And on the left-hand side of your screen, on the bottom, you'll see the Arduino Uno R3, and above it, the expansion board. And the Arduino Uno R3 runs the sensors.
Alrighty, so for the software components, we have the Django project, of course, coded with Python. The Django project has the Django REST framework for the API and a React application for the front end. We also have a MySQL Docker to hold our database. This is a neat picture we found online that kind of shows how the technologies interact with each other. The Django serves the React does the HTTP request to the API. The API uses the Django project to communicate to the database. And these are our hosting companies, Heroku and DigitalOcean, because, free trials. Alrighty, so this is a quick overview of the whole web application. You can see the user communicates with the Heroku app, which has the Django project. You can see the Django project is split in two, front end and API. And we have our DigitalOcean Cloud Docker container that hosts the database. So the front end structure is very straightforward. The user sends requests by URL with credentials. Depending on these credentials, you will receive one of three components: public components, user components, or grocery store components. All of these depend on your security features and so on. And the React application, as you can see, also communicates with the API. Now, the API is where all the magic happens. As you can see, this is a classic MVC structure. Our view sets, you can think of them as our controllers, our serializers as our views, and our models, of course, as our models, which interact with the database. The view sets take the data from the models and structure them based on the serializers and return them to the front end, pretty much. Here's a demo on using the web app.
Hello everyone, this is a tutorial on how to use the UB ShopBot web app. First step is going to the website ub-shopbot.herokuapp.com. If you don't have an account, you're gonna have to want to register over here. Let's say my name is Rick, last name Sanchez, the Z, email ricksanchez@gmail.com, password 123, password 123, and I'll register. Alrighty, so then I don't want to save that. Let's log in. ricksanchez@gmail.com, .com, password 123, sign in, bam. If it doesn't redirect you, that means there is an error in your login. Now let's search for a store. 06604. Currently, there's only 2 stores available at this zip code. Let's select store number 1. Alrighty, let's say now in this store we have apples, cookies, and broccoli. Different categories, different prices, different availability. Let's say I want to add 1 apple and 1 cookie. You can see the total items added to the cart on top. If I go over here, you can see the items in the cart. But let's say I forget to cash out and I log out. No big deal. All the items, sorry, Rick Sanchez at gmail.com. 1, 2, 3. And no big deal, all the items will be stored in the cart and it will be remembered. Now, if I do place my order, voila, my order was placed. Of course, there would be a payment method, but we haven't implemented this yet. Alrighty. Then I go back here. You can see this was cleared out. If I go to my history, it'll tell me about my orders, what my order number is, and if it has been completed or not. Now, if you are a grocery store admin, you would want to go to the grocery store login. This is for user trials if you want to see what the grocery store website looks like. I'll put in the first store, Bill Baker at gmail.com, grocery store number 1. 1, 2, 3. Sign in. Alrighty. So as you can see, there's a bunch of different orders over here. If we scroll down, we can see the newest order of Rick Sanchez. Also, as a store who would be using this service for their local grocery store, you can also manage your products and your employees, who's clocked in, who's off duty for your products. You can add a product, view all the add a new listing, like add more items, or change the current inventory. For your orders, let's say this order is complete. Alrighty, give it 1 second. And as you can see, it disappeared from this list and it was sent to the completed orders section, which should be down here. And we can log out and go back to user login. A quick security feature that you might notice is that if you try to access any user site without logging in, you'll be redirected back to the login page. This is due to the fact that the website uses token authorization to identify which users have been logged in. The same thing goes for the grocery store site. If you try to access anything, you'll be redirected to the login. There's also 2 different types of routes, one for grocery store, one for user, and they're never intertwined, so there's no risk of accidentally accessing someone else's information. That is all. Any questions, please let us know.
Oop,
Hello, everyone.
Sorry.
Oh, just a note, we didn't realize that the first video cut off at the end, so there's an additional video on the next slide showing the cutoff portion. But once Rick Sanchez places his order, the ShopBot will receive and fulfill it. You can see here that it's following the line using the line detection sensor. When it reaches the blue bakery section, the color sensor will read the RGB value and decipher what section it has reached. The ShopBot will pause, then align itself with Rick's desired item, which is cookies. Then the robotic arm will position itself in front of the item, carefully pick up the cookies and place it into the shopping cart. Once the item is in the shopping cart, the ShopBot will then continue on its grocery run. Since Rick did not order any vegetables, which is denoted by the green section, the ShopBot will pass by this section. Finally, the ShopBot approaches the fruit section, which is denoted by the red tape. Again, it will read in the color value. It will then align itself with the item that Rick has desired, which is an apple. It will carefully pick up and place the apple in the cart so that it does not bruise the fruit. And now Rick's order is complete.
Just for a note, this of course isn't a finished prototype. We still had a lot to implement. The main part being having the ShopBot receive the orders. Our plan for this was to attach a Raspberry Pi that would be in an idle state to receive HTTP requests from the API. That's how it would retrieve the orders. Once the Pi received the orders, it would activate the Arduino. The barcode will be attached to the Pi, and based on the code on the barcode reader, it will scan the items, and if the item was in the order, it would pick up the item.
So we're following more of a B2B business model where our clients are directly the grocery stores that have their own customers, and then they have the option to either integrate this into their pre-existing store or just have their customers work directly through our website, and then we still provide the customer service for their clients as well as the store. And our revenue streams are on the next slide, where the first one is the setup fee, which includes mostly just the robot cells, which is per unit a $300 fee because we manufacture them at $171. And then every grocery store pays a monthly subscription fee based on the number of orders per store so that we can accommodate stores of different sizes. And the service fee for the users using the app is 5% of the subtotal when they purchase an item. And then right now, this is just our proof of concept. So this will work more in the back of the store, not really in the forefront. But then after later developments, we're looking to have something that works in the same store with other people there in the same place.
So our main goal for future expansion is to use real-time object detection. For this, we'll add a neural stick, which will implement a CNN. The CNN will be used for the real-time object detection, and we will be implementing the YOLO algorithm. We'll also be adding a larger board so that we have more input pins to add like more inputs such as cameras and Bluetooth modules. And we'll also improve the car as well as the arm itself. And we'll also include a delivery service.
Here are some photos of the ShopBot as well as the grocery store demo.
These are references and the code links if you guys want to check them out. Thank you guys. Any questions, comments? Please let us know. And special thanks to our advisor, Professor Mia.
Okay, thanks so much. And I forgot to introduce the Professor Oshif Mahmoud is here, and also the Professor Mia, the vice of she is here. Okay, thanks so much for your attending. And any questions? And meanwhile, please, the group number 2, take over the screen.
Yeah, I just wanted to make a comment. Very, very nice project. It was nice to see very good software component as well as the robot working. So great job, guys. I know it's pretty complex project, but you guys, at least got to proof of concept level.
Thank you.
Thank you.
Professor.
Thanks, everyone. Really nice work.
Thank you.
Thank you.
Thank you.
My quick comment is the overall is very nice, especially as the Ochip mentioned. So it's a proof of concept, the project, and the target on the critical part, and great. And then in your business model, your main target is the grocery store. So my suggestion is it can be, I think the overall the POC the project can be applied to the warehouse.
Oh, true.
Instead of the grocery, it's all different shop. So if you focus on the warehouse, it's much easier problem. Then it's the more customer you can attract.
True.
Okay, very nice. Any other question from the student?
Let me add just one more comment. I don't know, Professor Lee, if you have shared with the students a couple of things that we need in the report. That Abhilasha, I think, had sent to you. Have you shared, Professor Lee, those requirements from the students?
I already mentioned that before the presentation regarding to the business plan and so on. So I didn't announce the today.
Yeah.
But
so to all students, there are a couple of things that in your formal write-up that we would like you to add. And we'll send you an email, stating exactly what needs to be done.
Okay, I will do.
Thanks.
Yeah, thank you. And the next, the group number 2, the smart beer dispenser, the Rodriguez, the David, and Kimani and Joel. Are you ready?
Yep, I'm ready. It looks like everyone else is here, I think.
Yeah.
Yep. All right. So we're group 2, and our project was the Medilock. We wanted to design a smart pill dispenser, like customized to a user. For our project, we have broken it down into several videos, starting with Joel and the construction of the hardware container. So I will play his video to start.
Hello, my name is Joel Williams, and I'm a part of the Senior Design Project Group 2, where we decided to create a pill dispenser to help with the integrity inside of the pharmaceutical world, like the CVS, the Walgreens. So, and even for patients, for them to remember to take their medications and so forth, and also to prevent unauthorized access. So therefore, my contribution for the team was to create a hardware representation. So we faced many challenges such as cost, where we were not able to print the file to the full scale due to a limited budget. Therefore, we used the facilities at UB and created a 50% scaled model representation of what the pill dispenser would look like. Hence, I have it in my hands. So this is the base, and right here would be where the LCD would have been placed. And then also we'll integrate two different forms of authentication, which would improve the security and also eliminate unauthorized access from different users that's not privileged to use the device. So for example, we'll integrate biometrics and also a keypad. So the keypad will be either a 6 or 8 digit PIN combination, and then also you have to use your fingerprint with the biometrics in order to access the pills. Then there will be a display that will list the pills that's coming out and also the user that's receiving the pills. We have a separator in the middle, so it spins, it's like a dial. There will be a step motor that's connected by the Arduino, where the software engineer folks on the team will be bridging that gap in terms of making the software communicating with the hardware. And it would automatically select based on commands from the doctor or prescriptions list. So we have the separator in there that separates the different pills by section, so you only get the dose that you need to get. And then also the lid, even though we did not get to a chance to get the translucent lid where you can see right through it, this is just a representation, as I said, 50% scale. So the lid goes on top, and then we have something that's called a gate. So what happens is that the gate goes right here, and then once proper authentication parameters are met, the gate opens and release that amount of pills that's prescribed by the doctor or for access from pharmaceutical representatives such as the CVS or the Walgreens. Okay, and then what we use to design this, we use this 3D modeling software called SolidWorks. And then after I designed it in SolidWorks, I then converted the files over to STL, and then I used those STL files to now enable the 3D printer at UB to communicate to print this model representation. And that is my contribution to the project. Thank you.
So now the next slide
Hello,
will
my name
show the like drawing itself. Of the things we wanted to integrate, we were able to integrate everything except the keypad. Unfortunately, it didn't come with the Arduino kit we had purchased, but we had started to code the like implementation for it for the future. The next video will explain how each individual part works, and I'll play that now. Hello, my name is Dave, and I'm with the Metalock group. My portion of the project was to program all the devices that will interact with our container. These devices were not able to be installed within the container because, as Joel explained, it was half the size we had planned due to the school's facilities. Eventually, when the device is able to be printed full size, it will support each of these devices being installed within them. For now, I'll explain each of their individual functionalities. Our main brains of the operation are the Arduino breadboard. This breadboard will act as the commanding officer for all of our individual parts. Then we have our fingerprint scanner. Once we run our first program that we have set up, a user is allowed to put their finger on the scanner to save it into the archive templates. A user can save in any amount up to, I think, 255 templates of valid fingers. Obviously, you wouldn't need that many. But once they're satisfied with the amount of fingers they have saved for entry, they can close this program and open up the main one. This program will then check every 5 seconds if there's a finger on the scanner. Once it determines there's a finger on the scanner, it'll match it to the saved templates. If the template is a match, it will open up, and if not, it will not. I will quickly demonstrate this on our LCD. The LCD will say place finger on scanner if it is searching, and every 5 seconds it scans the scanner. If there is a finger on the scanner, it will say matching. Once a match has been made, it'll either display invalid, doing nothing, or matching, sending a command to our stepper motor here. I will demonstrate invalid first. Invalid, try again. So now I'm going to switch fingers, and I'm going to put the other one on it. Valid, device unlocked. Now, as you notice, the motor moved. What this was designed for, originally we planned to have a motor that moved in a full circle, but unfortunately the power we have was not enough to supply this. So I moved to a cheaper one that would support, it was only 5 volts, I think. This only moves in a half circle. So what we did was the interval at which they're supposed to take their medicine, it is divided by 180. If this was a full circle, it would be divided by 360. So each day they take the medicine, it would move on to the next slot in our circular container. Once it reaches its full max, it resets to the starting point and it restarts again. Now, to demonstrate this movement once more, I will scan my finger. Finger detected, and as you can see and possibly hear, the motor has moved. I'll do it one more time just to verify. And see, as you can see, it reset because it reached its maximum point. So again, just to reiterate, the fingerprint scanner is the main security part of our project, and it will allow a user to be customized to their device. No other user can access their medicine. The LCD will be mounted on the board, and it will tell the user the status of their device and whether or not they have gained access. And the stepper motor will eventually be put into the center of our device in the circular container and allow the user to access their medicine per the given day. In the second part, I will explain how our device talks with our database and what functionality that has for users and doctor communication. Thank you.
Okay, and so for the second part,
Hello.
I'll play the video now. Hello, for this portion, I will be talking about the database as well as the alert system we have set up for the user and the doctor. To start, we will connect to the database. Inside of our database, we have 4 tables. User login, this is used on the user interface side, which Kamani and Rodriguez will cover. Patient info, for this demonstration, there will be 1 patient, and the email is very important. For doctor info, there will be 1 doctor, and the email is also very important. Now we will go to the assignment table, in which we can see that Dr. Kamani is assigned the patient, with 7 pills assigned to Dave that are currently within the Metalock with a 1-day interval. Now to demonstrate, I will unlock the device and then refresh this page. We can now see that there are 6 pills remaining. This signifies that there was a successful transaction between the user and the device, and the user has taken his medicine for the day. If we go verify the Metalock email that we have established, we can see that Metalock has sent Zeker348, which was the patient email, an email that says, "Good work, you have successfully taken today's medicine. Please make sure to take it tomorrow." Now, we have set an alarm within the system for a low medicine count. Give me 1 second. If I scan my finger again, and then I refresh the table, we can see that there are 5 pills remaining. When a user gets to 5 pills left, both the user and the doctor will be alerted. We can then pull up the email, refresh this, and we can see that the patient Zeker has received an email that has said the original message along with "You are running low on pills. Please reach out to your doctor." In the link to the doctor's email shortly, it says you have 5 pills remaining. This will continuously update until they are at 0 pills. The doctor also received an email saying your patient has low pills. Please email along with the patient's email to let them know to schedule a checkup. This will work as a system of alerting both the user and the doctor that they need to schedule a checkup and that they are running out of medicine, as well as somewhat rewarding and alerting the user to a successful transaction of medicine. This will continue to update, and eventually there will be multiple patients, multiple doctors, and our device will pull all of these records and interact with them accordingly. Thank you. And now for the final part of our project, we have a user interface designed by Kamani and Rodriguez, and they will explain it more here.
Hello, everyone. My name is Kimani.
Hello, everyone. My name is Rodriguez.
And we're going to be showing you the website we made for our project Metalock. So this is a homepage of the website. You have the features of Metalock, you have why we chose Metalock, you have how it will help us, and then you have who made it. Right here on the navigation bar, you have a homepage link, a login link, and a About Us link. If you click on the About Us, it brings you to the About Us page. It shows us a little bit about us and Metalock. And on the right side, you have our names and some question marks under it. Those question marks were supposed to be replaced with pictures of us, but unfortunately, we weren't able to meet up and take some pictures so we could put it on the website. And then to get back to the homepage, you just click on the icon in the top left. And then now I'm going to click on the login so we go on the login page and Rodriguez could explain everything from there.
Yeah, so once you click on login, it takes you to the login page where you can log in if you already register, or if not, it's going to take you to the register page where you can register. And on the register page, you have a username. You can enter a username and a password. Username. And you can choose if you are a doctor or a patient. So let's register as a patient first. And I'm gonna log in with the username and password that you just made. Log in, it's gonna take you to this page where you can enter some information about yourself, first name, last name, your address, and your email address. Once you're done, it's gonna take you back to the login page, so now you can log in as a patient. So now you log in as a patient, but since you don't have any doctor assigned to you as of right now, this page is blank. Once you get a doctor assigned, it will show your doctor and the pills and everything. So now let's register a doctor. Password and doctor. Register. It's gonna take you to the login page. Now let's log in as a doctor. And enter some information about the doctor. First name, last name, address, and email address also. Email. Once you're done, it's gonna take you to the login page again, and now you can register the doctor. You can log in as a doctor. So once you log in as a doctor, it's gonna give you this page where you can enter information about your patient, patient's name, the total pills that they're going to take, the name of the pills, and how many days they're gonna have until the refill. And you click, once you're done, you click on add, and it adds the data to the database, and then you can view your patients. These are the patients that we just added with the the patient names and the total pills and stuff. So it's gonna, now you can log out and you can log in as a patient. You will see that you have a doctor assigned to you. There you go. So now you can see that Dr. F is your doctor and the pills that you need to take and how many days you have until you have to get a refill. So then you can log out So this is pretty much how the login and the register page works. So Kimani gonna talk about some of the.
So since we're running out of time, Kimani just briefly highlights some more of the, user login information in our database and how it interacts, as well as a brief description of the backend code for our user interface. So with that in mind, if I can. So in conclusion, we have some future additions planned. Obviously, as mentioned, we wish to implement a keypad. We want to continue to improve the functionality and design of the user interface. But the biggest thing that we wish to do is get a full-size container so we can actually mount the hardware and have a operational unit itself. So obviously everything works individually, but we want to make sure everything works as a whole unit so we can provide something to an end user. Otherwise, we just want to make the device more user-friendly in general. That basically concludes our project, and any questions or answers would be appreciated. Thank you.
Thanks so much. And group number 3, please take the screenshot. Any question to group number 2?
Can you guys elaborate a little bit on the economics of the project?
In what regards do you mean?
Like if you were to make it commercial?
Sure. It's a little bit tough right now because we are not too sure how much it would cost to develop the base unit. I know Joel had gotten some quotes from some 3D printing companies, and it was a little bit ridiculous, somewhere around like $200, $300 to reproduce it. So we would have to shop around and see which would be the most affordable. Maybe we can get it printed in parts. And once we have developed the base unit, the rest of the hardware isn't really that expensive. I think it's like $60 top. So we would be wanting to produce this unit for security reasons and stuff, and not as much for profit. So we would not be looking at much of a wide profit margin. So we would be charging the user only a little bit above what it costs to make and maintain the device. So I guess the main factor here would be finding a reasonable producer for the base unit.
One important aspect of the senior project is an economic analysis and economic plan. So just make sure you have that included in your report.
Yes, I'll have to meet with Joel because I believe he has the individual quotes, and it may be cheaper if we produce it in bulk. So I guess that's just something we'll have to discuss when we write our report. But,
okay. But
any other questions?
Very good project.
Thank you.
Any other questions? Okay, thanks so much for group number 2. And group number 3, the smart wheelchair by the Abdullah and the Ali. Are you guys ready?
Yes, Professor.
Okay, go ahead.
Hello, everyone. My name is Ali Al-Khaldi, and my teammate is Abdullah Al-Khaldi. Today, we will be presenting our final presentation. The next slide. Objectives included a plan to build a simple and easy-to-use IoT-based controller smart wheelchair. Keep the production cost of the chair cheap. Have a voice commands for fully paralyzed patients, easy control for patients with one hand researchable and possibly easy to make the chair stand for helping patients to reach different heights and having a simple emergency notification. Next slide. Yeah. Scope included the following. It improves the human-friendly interface, allowing users to give higher-level directional commands. It is a reactive system and doesn't require maps or planning. It has a lot. It has been developed in indoor environment work and outdoor environment work, all being programmed by artificial intelligence. It will also help people who are not able to move anywhere. Next slide, Abdullah. Yeah. Here are a few existing systems: attended propelled chairs, motorized manual chairs, mobility scooters, single arm drive wheelchair, standing wheelchair. The idea for our project to build a voice-operated wheelchair. A few patients, such as disabled people and multiple sclerosis type, cannot drive joystick-operated power wheelchair. They are dependent on other people or helpers to move from one place to another, and in such a way they don't have the freedom of mobility. The powered wheelchair motor will control and drive system, which consists of microcontroller and DC motor, is a great solution. The hardware we used is a Raspberry Pi, a microphone for voice. Also, we use the touchscreen sensor for movement that will be easy for the patient to use. The LCD screen on Raspberry Pi is a touch-based TFT screen. Our mechanical parts include DC motors, which are used to drive the wheelchair. We also use the chain drive, which is the drive mechanism. Finally, two 12 voltage, 32 amperes maintenance-free lead-acid batteries are used. We used Raspberry Pi OS and Python code for voice recognition and Arduino IDE to program the motor drive. This is our block diagram. We used a microphone with the voice recognition and software to recognize the basic commands, as well as have sensors to find obstacles and help navigate the two motors. We have two motors that will function for movement, as well as one motor to make the chair stand completely straight. The remote is no, go back one. Yeah, the remote is a built of touch screen for easy use for the patient for movement. Next slide. Smart wheelchair are becoming a popular research platform for adaptive systems and human-robot interaction. A robust voice interface is designed for human voice recognition. The recognized voice commands are used to generate voice control commands to the low-level DSP voice controller, so that it control the motion of the chair according to users' intention. The voice controller controlled the wheelchair. Our finding were that this was an extremely useful system for the users who have restricted limb movements caused by some diseases such as Parkinson's disease in disabled people. There are some practical implementation. This system is novel integrated approaches to real-time voice direction, modulation, and recognition. This is analyzed. It has a lot of originality and volt. Google's API, we need to install the firm speech-to-text SDK for Python so that we can stream audio and get results. This is done on the command line, and we run the following voice libraries. We can start using voice SDK. Limitation can occur. Limitation can occur, such as it cannot correctly understand every word in pronunciation, but it is a good start. Also, noisy conditions disrupted. The voice recognition we have to recognize words like move forward and move backward and stand up and stop. When the word is heard, the commands from Raspberry Pi are sent to the chair. This is our pin diagram of all pins on the Raspberry Pi. We use the GPIO pin 18 as input and output.
Hello everyone. This is our circuit diagram. We connect the mic to PI using USB, and the Raspberry Pi voice SDK converts the words. This is just a circuit of the voice recognition. There is our power calculation based on the input from our last presentation. We calculate three situations to calculate moving acceleration of the motor on the chair for 15 seconds or 14 seconds and 7 seconds with the 14 kilogram weight, and all three tires of average acceleration was about 0.23 meter per second. Similarly, we did calculation for the power required on the motor. Since we have one motor, we calculate that each motor should be at least 16 weight and 100 RPM to move the person with the weight of 14 kilogram and moving speed of 0.21 meters per second. Here our voice control flow chat that was chained and Python control the speed of motor and do action based on the word spoken into the mic. The keyword are sample and hard coded. We will show you that in the video demo. This is our final prototype. Coming to our conclusion and future work, the development system provide enhanced mobility of elderly and displaced people. A report PI is designing for voice-based recognition of the chair. The recognized voice command are used to generate motion control command so that the chair can be controlled according to the user intention. There are certain ways to avoid unnecessary movement caused by noise or voice command and are limited to certain keyword. Advantage of our project are that it has an automatic operation, it's user friendly, it's easy to use, it will allow the navigation and the operation. The idea is open to future upgrade. The disadvantage of our project is on the battery use, and the voice command can be issue. It's not perfect to make it good. We may have to buy some voice API. This is because the technology is not mainstream. Now, please enjoy our video.
Hello everyone. Today we are presenting our senior design project as a smart wheelchair with a voice remote controller. We have basically two PCBs. One is to control the four motors that take care of all the movement, and the second PCB is remote controller. In the chair we have two motors here and here to make the chair stand up, as you can see. And each wheel has two motors here and here for full movement, front, back, left, and right.
Hello everyone, this is our second bot. Here in the second PCB, we have a Bluetooth control that will allow the phone app to contact the device for sending an alert message. In the future, we can use DSM chip. Also, we have Raspberry that is the brain of the system. We have a 4-inch LCD touch screen with the control. In the future, we can have the same UI of our screen on a smart watch. As you can see in the LCD, we have all that control for moving forward, left, right, and back. We also have a button for making chair stand up and stop. The help button will send a message via Bluetooth. Finally, the microphone here will accept voice command.
Now I will show you a small demo of the controller. As you see, when I press forward, as you can see, the wheel move forward. And same backward. Also, I have a stop button to stop it. Here, when I press forward, then the stop button, it will stop. Backward, stop button. When I press stand up button, it will stand up. The chair will stand up. When I and when I press sit down, it will sit down. Now Abdullah can show you the control with the voice.
Hi everyone. As you see, we have used a Google Text to Speech SDK to convert voice to text command. It's not very clear, but more training, we can make this very perfect. Now I will show you the voice command for our smart wheelchair. The first command is move left. Move forward. Hello everyone. This is our Bluetooth app, and this is the wheelchair. If your friend or somebody in the wheelchair and he falls from the wheelchair, he can push help from his Apple Watch or from his iPhone app. You can see it, the help, what he needed.
And now I would like to thank Professor Mahmoud and Professor Lee for everything to advising us about this project. And that's it. That's what we have. If you have any question.
Okay, great. The group number 3. If you have any question, please go ahead. Meanwhile, the group number 4 take over the screenshot and be ready. Okay, any question to the group number 3, the smart wheelchair?
Once again, good project, nice implementation of hardware and, very good design.
Thank you so much, Professor.
Okay, I have a quick question. So if you develop the smart wheelchair, how much it costs roughly? Then because usually the wheelchair, the electric wheelchair is really expensive, and there are a lot of scam also in the market. So what do you think? What will be your price?
$4,000.
4,000?
Yes.
Yes.
Yeah, so I think that probably should be the
around this price, Professor.
Around the price. So why don't you roughly plan for such a price in case you develop the real size the wheelchair, but the product definitely better than the existing one because it's a lot of voice control and the API control. So please.
The motor is expensive, and the voice API is free because we built it.
Okay.
Yeah, just make sure you do an economic analysis. If you were to market it, that should be part of your project report.
Yeah, I will put it in the report, and you will see it, Professor.
Okay, good.
Okay, so any other questions to the smart wheelchair? Okay, great. Thanks so much. And group number 4, the quick and easy recycling by the Anab, the Asher, Nikita, and the Jane. Are you guys ready?
Yes, Professor.
Okay, go ahead.
Good afternoon, everyone, and welcome to the Group 4 presentation. I am Arsh, and along with me joining our...
Hi, guys, I'm Nikita.
Hi, I'm Jane.
Hi, I'm Enoch.
Our senior design project is quick and easy recycling, and our group advisor was Professor Bilasha. Next slide, please. Recycling is very important to protect our environment. As we can see, situation is slowly degrading as we can different types of pollutions around the world, and it's crucial that we need to step in and do our part to help. Quick and easy recycling is a sorting machine that would help people save time, and they would spend sorting bottles and cans at redemption programs or local stores. This machine is the machine we have designed is um, that would help like controlled by the user via with our website, which gives manufacturer option to sort them by different manufacturers, and also it saves the transaction data so users can uh, check it out later. Uh, the reason our machine is different from other like local market machines is because we can sort the cans and bottles according to their manufacturer. Could you change the slide, please? There are like large manufacturing machines already in place. If you go to your local Stop and Shop or any grocery stores, they already have sorting machines, but they take a lot of time to complete a transaction, and you have to place one bottle at a time, and they will scan that and take a lot of time. Other government and private companies already taken this issue in their hands and started using this machines, but major problem is they take a lot of time, and downside is the machines are very expensive. Average cost of one particular machine would cost them around $8,000 or $10,000. This is just the price of the unit, and maintenance cost and cost of transport from the machine to the company itself, it's not accounted for.
Okay, so the initial idea was that the machine would consist 3 conveyor belts that are running simultaneously. The bottle would start at the first belt, then travel to the smaller middle one where the barcode is scanned, and is then pushed into the third one where the cylinders and the sensors are going to work. As you will be seeing, our final project looks completely significantly different from the first one that we presented. So due to the issues and problems we faced while coding and building the machine, we made the necessary changes that we wanted. Currently, our machine consists of 2 conveyor belts that are powered by the stepper motors. They are separated by a barrier which is powered by a servo motor which turns 180 degrees. The barrier will hold the bottle in place as the barcode is scanned, and the bottle is then pushed into the next belt. Once the barcode is scanned, the barrier rotates and pushes the bottles into the second belt. The barrier actually rotates 180 degrees to do so. Then, depending on the manufacturer, the user selects either the cylinder 1 or cylinder 2 is activated, and if the bottle doesn't match to any of the manufacturer that the user select, then it goes straightly into the user bin. Then the cycle repeats itself over and over until the user ends the current transaction. Next slide.
Hi. So for the hardware part, we use 2 Arduino board. One was used as a main board for everything else, and the other one was used for the motors, the stepper motors, and we use the CNC shield a CNC shield for the steppers. Since we wanted to use 2 steppers, so we decided to use a shield like that. With a shield we can actually use multiple steppers. So we also use a solenoid valve. We use two of them, and we use a cylinder. We use 2 cylinders the cylinders are connected to the belt the valves. So since there's 2 valves, we use 2 cylinders, and we use 2 servo motors. We had 2 NEMA 17 stepper motors, which are very powerful. With those type of steppers, we can do a lot of things with it. We can build stuff like printers. They are very powerful. And also we had the 12 volts power supply, because Arduino only provides about 5 9-volt external power supply. Yeah.
Okay, so as you can see, this is what our final product looks like. It's still considered a prototype, as we would add a lot more finishing touches to make it look more professional and streamlined. But it is very simple to manufacture. So as you can see where my cursor is, this is belt 1, and this is the barrier powered by the servo motor. And then right here is our webcam that we're using. We originally planned to use a barcode scanner, but for some reason it wasn't working. So we did some research, and using OpenCV, we're able to use the webcam to detect the barcode, which worked out really well. And right here is our website, which is our user interface, which you'll see in the next slide. And then this is our second belt. In this box, it houses our valves, and then all our other wiring and boards, so that it looks very nice. And then right here is our tubing that connects to our air compressor. Here is both cylinders with some like plastic board kind of, so that it increases the surface area, so that it will push the bottle more accurately. And then right here is our bin 1, bin 2, and then right here is our discard bin, which is any bottle that doesn't match either manufacturers that the user sets. So here is our website. We use Django for this, and here's our home screen. And then here is the menu. So this is what the user will interact with. So there's a drop-down menu here. It doesn't show in the video for some reason, but it has a lot of different bottle manufacturers. So they can choose 1, 2, or none, any manufacturers, and then they just have to press the start transaction. And this transaction directly correlates to the transaction you'll see in our video. Oh, we did. So right here, I'm scrolling down the list. It doesn't show for some reason. So I'm choosing Autograph, which is Pepsi's manufacturer, and Brady, which is root beer's manufacturer. And then right here is our page, which is connected to our database we have, which saves each transaction history. And right here is just shows everything. And then, there we go. So this is the transaction you'll see in the video. And then we also have a search button right here, so we can read it. And then this just gives you, again, all the information on it. So then this is our demo video. So as in the website, you'll see right here. So for bin 1, the user chose Autograph, which is Pepsi's manufacturer. And for bin 2, it chose Brady, which is root beer. So right now, the Pepsi can is on the first belt. And then it gets right here. And then the webcam scans the barcode. And then the barrier will rotate 180 degrees, pushing it onto the second belt. And then cylinder 1 pushed the bottle right into bin 1. So now this is root beer on the first belt. Again, the webcam will pick up on the barcode. The barrier will rotate, and then cylinder 2 will push it into bin 2. And now this is not root beer or Pepsi. So what should happen is that neither cylinder should push, and it should just go directly into the discard bin here. So you'll see it cuts barcode, did the barrier, and then it went right into the discard bin. And this can be used for as many bottles as you want for each transaction. But for this demoing purposes, we just did 3.
So for future expansions, we are planning on expanding the present system so that it will be more efficient and convenient to the users. One of the expansion idea is to improve the existing system so it can take multiple bottles and cans at once instead of one at a time. This would save a lot of time for the users. We are also planning on using more bins and cylinders to allow for more sorting capabilities. We are also planning on printing a paper receipt or a QR code receipt when the transaction is over so that the user can remedy the points they got in form of groceries and etc. Another change will also be allowing the user to choose what category they want to sort by. Like for example, we are using manufacturer's name for this instance, but we can change it to bottle type, etc. in the future. We are also not using any sensors right now because of the problems we faced for coding for the sensors in Python. So for future, we want to add sensors also for more precise reaction from the cylinders. We are also planning on getting better webcam or barcode scanner for faster scanning of bottles and cans to reduce the time. Next slide, please.
And just before we do questions, I just want to thank Professor Abhilasha for helping us out on this. We couldn't have done it without you.
My pleasure, guys.
Okay, great job. And meanwhile, the group number 5 take the screenshot. And if you have any question to the group number 4, the quick and easy recycling, go ahead.
Yeah, just a comment. What if the barcode has some kind of, it's obfuscated so that you can't see it properly? So in that case, it seems like it will go in the discard bin, right?
Correct.
So would have been, I mean, as a future expansion would be nice to put an object recognition on it on top of the barcode.
Definitely.
And also if the can was slightly crushed or something. So, adding object recognition, I think would make it, pretty neat, but very neat idea.
Yeah.
Thank you.
Thank you.
Thank you.
And my quick question is, who will be the target customer if you commercialize this one? Is it the retail shop or the something, the house, or the what will be your main target?
Local.
Yes. So
It'll be local grocery markets or like redemption programs where they have like person who manually sort the cans and bottles, or the local market where they have machines which cost them a lot of money.
Okay, any other questions or suggestions? Okay, thanks so much. And group number 5, the Clean Hand by the Anastasia and the Christopher. Are you guys ready?
Yeah, we're ready.
Okay, go ahead when you are ready.
Hi, everyone. My name is Anastasia, and this is Christopher representing CleanHands project that is advised by Professor Mahmoud. Next. So our idea was to create a system that will use real-time action recognition to detect the start and end of hand washing, thus determining the total hand washing time and see if people comply with the CDC guidelines to enforce good hand washing practices in establishments where it's really important, like hospitals and restaurants.
So our proposed product is basically three parts. One is the Handy AI, which will perform the task of video segmentation and action recognition to perform the detection and delivering the hand washing time. We also have a video-based monitoring system, which is basically the Raspberry Pi with the camera, an LCD screen, and an ultrasonic sensor. We also want to provide the admins that will be buying our devices a web application so they can keep track on what is their hand washing culture. Okay. And this is the assembled hardware. To your left, you see the top view of the LCD sensor, the camera, and the breadboard. And to the right, you will see that behind the LCD, we have the Raspberry Pi, and to the Raspberry Pi, we have connected the Pi camera and the breadboard. So everything is connected to the Pi at the back. So this is our main hardware. And we are now going to show a demo for how the hardware should be assembled in the sinks.
Okay, so here is our setting of our prototype. Here is our ultrasonic that points to the legs of the person who approaches, trying to detect the action. In real settings, while we will be integrating, we will mount it beneath the sink, so the user, the person who comes to wash hands, wouldn't even know about its existence. So ultrasonic sensor connects to the breadboard, which connects to the Pi at the end of the LCD, at the back of the LCD screen. Here is our Pi, and from the Pi we also see the black cord, which this black cord is our camera that we sort of mounted, but it's gonna be mounted to the ceiling to have the top view. So it points to the sink, and we can actually see what the camera is seeing right now. This current sink with my, with, I don't know, my hand.
So that was the hardware demo, and let's see if we can do this software architecture. So this is how the software architecture is. I think we're really proud of what we built because it's quite intricate. So we have basically 4 components. To the bottom left corner, we have the Raspberry Pi. So the Raspberry Pi, our application is mainly an electron application, but it talks with 2 other processes. One process is the Pi camera, and the other process is the ultrasonic sensor. So this is what tells the electron app, hey, start the Pi camera and start recording. Now we have our server, which is like a facade. Unicorn is our production ready server that handles all the traffic. And behind Unicorn, we have a Flash server, which talks to the Postgres database. So how it works is that the Unicorn supports HTTP and REST, but it also supports WebSocket and Socket.io. So what it will happen is that the Electron app will send the video to Unicorn, and the Unicorn will redirect those frames through WebSocket to our Handy AI that is actually running on Google Colab. Why are we hosting it on Google Colab? Is because our network uses GPU, and in that way we are not limited by the hardware on the Raspberry Pi. So that's why we use WebSockets to communicate the Pi and our Handy. Now, and the other component is the admin application that is currently hosted on Vercel, and it's basically a React app. And all of our backend infrastructure is currently hosted on DigitalOcean. And essentially, you can take it from here.
Yes, so unfortunately, when we started looking for it, we didn't find any publicly available hand washing data set that satisfied our needs. So we had to collect it. We looked on Kaggle everywhere.
nothing that works for us. So we collected 130 videos recorded on phone from our friends and acquaintances. We actually put up this small website to give the instruction sample videos that you see in the bottom left corner. Then once we received all of these videos that people submitted, we cropped the videos into the square because the neural network uses convolutions like matrices. It needs videos to be squared. And we also set everyone to be 30 frames per second rate so that they had the same rate. And then we wrote a Python script that will split all of these videos into frames. So you can see here different frames, 120, 132, 133, and all of these frames from one single video. So we split all of the videos like that to have the frames. Next. So once we get the all the frames, we also needed to define main events that the handy will be determining. So there are 4 main events. When wrist appears, that is defined the first time when the whole wrist appears, not just fingers, the whole wrist is in the video. The second one is start hand washing. That is the first time when the hands get together. The third one is end of hand washing. This is when the hands separate and the person starts going to close the faucet, close the water. And the third one is when the wrist disappears. Also, the last time it's in the camera view when we see the complete wrist, not only the fingers. So after we defined the main events, we could go to labeling, and we labeled it all. You could see the struct in MATLAB that has 117 rows. Some videos we had to discard because they didn't didn't have the hands. So we labeled video name. Then we have these 4 events: wrist appears, start hand washing, end hand washing, and wrist disappears. That's the frame number that we determined from the previous script that got us all of the frames. And then we got total frames and also side and top view, because we don't know where the camera will be mounted. It works for both, from the top view, camera looking down to the sink, and side view as well. So the actual architecture, the actual neural network, the first iteration, we just did the 4-layer CNN, which is a simple binary classifier. If hands or sink, that determined by one single image, is it hand, is there a hand, or is it a pure sink? We got good accuracy, but there were issues with this model because first of all, it thinks that it's hand even when it has just fingers, so the hand didn't even fully appear in the video. And the second issue, if the person goes to reach to the soap and the hands are out of the image, it thinks that, okay, it's a sink, the hand washing is finished, when it's not in reality. So we needed to go for the video-based architecture, and we chose SwingNet architecture, which is basically, which was close to our needs. What they were doing, they were determining 8 events of the golf swing. When the person starts, when the person kicks the ball, when the swing is really, so basically several events of the golf swing. And you can see the actual original architecture. It has the mobile net, which is just a deep convolutional network that extracts features from every image. And then it passes us to LSTM, which basically gives us the temporal component, because it sees several sets, like 64 frames at a time, and it knows what happens before it and after it, because it's bidirectional. So we used this architecture, and when we passed it first time through our data set with small adjustments, it didn't give good results. And the issue was that our events were much more sparse. So the golf swing is just 5 seconds, and it has 8 events within this 5 seconds, but hand washing can be 20, 30 seconds. And we have only 4 events that are much more sparse. So the LSTM didn't see events close to each other. So it couldn't infer the sequence of events. So it could mark me end of hand washing before the start of hand washing frame. So we needed to make events closer to each other. So we started brainstorming what we can do with it. And we were thinking of cutting the middle of the video when the person is washing hands, but we didn't want this jump of pixels in the middle. We were thinking of adding more events, but it is adding labeling, it's time consuming. So what we came up with is we reduce the frame rate. So we started taking every third frame. So 10 frames per second, which makes all of our events close to each other, 3 times closer than they were. And on top of that, we also increased the sequence length of LSTM so that it saw more events. It had the ability to see more frames at a time and ability to see 2 events, even though they're pretty far from each other. So by these manipulations, we put the frames closer to each other and allowed the network to see events closer to each other and determine what are the events that we are looking for.
All right, and time for the truth. So we'll see how Handy actually performs.
Okay, so this is our Handy, which is our AI that does the hand washing video recognition to determine the time. You can see that the model is loaded. That is our pre-trained model. And you see that it is connected to a WebSocket, meaning that Handy is ready to receive input frames from the Pi camera and give the results. So right now we don't see any output from the no frames selected from the Handy, even if I will reload to show you. And after, this is our app on the desktop that shows the steps that the person should follow, recommended by who. And now Christopher will approach to wash his hands, and I will show you in Handy what are the frames that that Handy determined as start end of hand washing. Okay. So this is the app that keeps looping the steps. And Christopher approached, and we actually see here that it started the capture because the sensor can sense him. He's washing hands. The camera is recording it all. The app for now keeps showing the what steps to take. Okay, he is leaving, so you can see that the stop capture appeared, and which means that, and the hand washing time is 20 seconds. Please wait after washing hands. So 20 seconds, that's how long he was washing. And now if we reload our folder, we will see the images, 4 events that our Handy supposed to determine. So this is this confidence score, and this is the frames when it thinks Christopher's wrists appeared, when he started hand washing, when he ended hand washing, and when his wrist disappeared. So we're gonna start with wrist appears. This is when the wrist appears in the frame for the first time. That's when he moved his hand on the 27th frame. Then the start hand washing is this. Start hand washing, that's when he started hand washing as his hands were together for the first time. Then we have the end hand washing. And hand washing, this is when his hands separated. And then we have wrist disappears with pretty high confidence. That's when he is taking off his hands from the video. And the result of that was sent to the
Yeah. And oh, sorry about that. I stopped the share. It's a mistake. So, and I want to keep the video short because we are running out of time. But that's basically how the Handy works. So,
okay. So this is.
Let me go to the next slide. So let's just quickly go over the admin application. So this is our application that is currently hosted on Vercel. So we copy and pasted our pictures from our prediction to show how it works. So wrist appears, start hand washing, and wrist appears. So we can basically log in, and I can just give the only user that we have currently here And we can display the number, the name of the person, the email, and organization. The person has the ability to edit the personal information. For example, I can just call, I can do it. So if we want to do that, I can just change, for example, I can just call it, let's say that the person wants to call himself Willie. I can submit the names and you immediately see the changes. That is, now it's Willie Black. Now the person can also update their password in case they want to make it more secure. Now, if we go to statistics, we can see a graph per day and the average hand washing time. You can see 418, 420, 422, and 433, and the average hand washing time. And this person has two devices, so we can toggle between them. This device only has one record that you can see here. And the person can also see, I can modify the end date as well. And the last part is the report. So the person can also see a report of the minimum time, maximum time, number of users, the date, and the average hand washing time as well also per device. And that's the demo for the web application. And let's continue to the last part of the presentation, which is basically cost analysis. So we basically have two options. Our budget-friendly option is around $55, and our regular option is more expensive because it has the LCD and the case, and that's around $270. Now, our business model, we are basically mostly doing subscription-based. So we do are charging a one-time payment for the installation because we do have to install it near the sink so people don't see it. Now but we also charge you for the Raspberry Pi and the set itself. For the budget-friendly and the normal option, we get a 20% margin. Now, where we get most of our money is from the subscription to the Handy AI. And this is the glossary of how much we're charging per device. Now, that's the real time. Another option that we're giving our users is for them to generate one report per month in case they don't want to check their statistics constantly. And finally, the marketing strategy. We basically want to reach out organizations where high hygiene is really important, the hospitals and market. We want to pivot our idea on our competitor that is CleanHands, Safe Hands, that already proved the existence of a market because they're a successful business onto this. Now, we also want to collect more data to improve Handy's detection accuracy and validate its result in a peer-reviewed study. And we also want to prove that Handy hand washing time detection is better at reducing healthcare associated infections and liability. Our competitors, they only check if someone washed their hands, but we check how long they wash their hands. Does make a difference.
Yeah, because they basically just check if the person used the soap or didn't use the soap after he entered and leaves the restroom.
Okay, thanks so much for the presentation. Any questions? And meanwhile, the group number 6, they take the screenshot, then they'll be ready. Any questions for the group number 5, CleanHands?
Excellent job, Anastasia and Chris. I was just noticing in your, I know you have a very limited training data set for the 4 events. The second and third, I think that was the start of the hand wash end of. The confidence seems to be a little bit less. Am I right or no?
It is correct, because I think the reason is that when the risk appears and risk disappears, it's kind of uniform for everyone. Everyone is like similar, but when they start and end hand washing, it's a bit different poses and everything. So that, yes, I believe that when we add the data, it will be better. That's why right now the Handy actually, to give you the final time, it uses the start and when risk appears and risk disappears and just subtract a couple seconds to give you the result, because the start and end of hand washing is around like 60% accuracy. It's not that good, but I believe more data will solve it.
Sure, definitely. But you guys did a great job. You know, it's a difficult project. Very impressive how you put everything together.
Okay, any other questions?
I have one. I think you guys did an amazing job. I just have one question. You mentioned kind of like hiding the sensors eventually. Do you expect any sort of like pushback from user privacy, or how exactly would you deal with that?
So that's something that we are thinking about. We will need to go through a validation process, because although we use data to train, we are not storing those videos. So those videos only pass through the network. We don't store them.
Okay.
But again, we do need certification from like privacy agencies, like, hey, this person doesn't collect your data. But I believe that once we have that, because it's certification, so people wouldn't be scared of using it, because we don't collect data. We only pass it to the network.
Okay. Amazing
Okay.
job, by the way. Thank you.
Okay, thanks so much. And finally, last one, the group number 6, the PSY BOT by the Ahmed, the Segun, and Justin. Are you guys ready?
Yes.
Okay, go ahead.
So hello everyone. This is Group 6 PSY slash bot controller. So presented by Shagun, Ahmed, and Justin.
Hello, how are we doing today, people?
Hi.
All right.
Okay. Our project goal is to build a car that can be located via GPS and tracked while also being controlled via a mobile app. Such a model that we built can be used in any system. Next slide, please. Major feature of our system are security. We use a secure web server to access the GPS location. We use unencrypted Bluetooth communication to secure the connection between the car and the app. The tracking is real-time using a GPS model. The battery consumption is less, and the battery can recharge with the drive of the car. This is not built but can be added. Overall, the car is built in a low budget and uses less power. Next slide, please. Such a remote control car can be used for disabled people, air travels, airports, and control areas like large malls and service industry. Next slide, please. Here is the block diagram of our project, as simple as it seems. We use a charge controller that power the system using a lead or lithium battery. We have a microcontroller connected to the Bluetooth that is connected to the app, and motor driver that controls the two wheels.
So for the hardware components, we have Raspberry Pi kit, which comes with a features such as wireless and onboard Bluetooth, Sinotrack GPS, Sinotrack vehicle GPS tracker, which shows a real-time where the GPS is located, LiPo battery, Bluetooth module, which can be interfaced with laptop or mobile phones. So the metal chassis, which has a large base for customization and electronics, and it's easy to do for custom add-ons as well.
So on the front end, on the supply, we have my iPhone, not iPhone, Android, with the application that we set up for the Bluetooth device to connect to the Raspberry Pi to control our toy miniature car. On the back end, however, the Python execution code is right next on the right, well, partially there, is several things. We have our GPS tracker code in there, as well as our rigging to set up the controls for the Bluetooth to control the motors, to control the vehicle, as in turning, moving, and doing other sophisticated stuff.
So this is our hardware system. So on the left is the top view, and on the right is the side view of our system. All right, so in the video, so we're gonna be showing the circuit where the Raspberry Pi is connected to main PCB with motor driver, and on the top is the reset button.
We don't hear. There's no, I cannot hear any audio.
Oh,
While sharing, you should share with the sound.
I made sure the sound is on. I'm not really sure why.
On the sharing panel on top, it should say sharing options, and you should say see
Okay.
sharing sound.
No.
Can you guys hear it now?
No, maybe stop the share and then reshare and make sure it's checked.
Okay, give me a sec.
Yeah, sorry for the technical difficulties, everybody.
No problem. It should just be on the bottom left once you click
Okay,
share.
I got it. Got it.
Okay, we have sound now.
So right now we have our power button, our reset button, our GPS receiver in the back here. And then when we open it up, that GPS receiver is connected to our GPS right here, which is also connected to our controller for the motors for here and here. That is connected to our Raspberry Pi that's just crushed in the corner over there, but that's basically our main controller. And then the wiring is just a mess, but we'll have to make do with that. Hi, hello everybody. This is Justin here demonstrating on how to use the Bluetooth application. So I go down here into my last app category and I go to Bluetooth controller. Here it says select the device. So right now it's connected to my watch, so I don't want to do that. So I'm going to do the drop down menu and click on Raspberry Pi and then connect. At this time, I should be turning on my device. Oh, not bad. That's when the device is off, it'll give you this notice. Connection failed. It's like, all right, try again. All right. The device is on. Give me a sec. All right. Kink we have to work on, but it was connected there for a second. All right, there we go. Now it's connected. Start controller. This is the screen where you're going to see the controller. So if I move forward, the device is going to move forward. If I move back, the device is going to move back. Left. Right. And yeah, there it is. That's just as simple. The A, B, C, D, E, F, Gs don't really do much. I haven't programmed them to do anything, so yeah. Thank you. Hi.
So this is our Bluetooth system working with the hardware chassis.
The live demonstration.
It's me, Justin. Sagoon's recording right now. Right now we're just doing a little demonstration. I have the controller right here connected to our device. It works. Finally. Not the best, but that should work. And then, well, we'll have to go onto the computer to show them that it.
All right, for the GPS location on the back, I had to use a website called IoT Gecko just for the location purposes. And then, for example, right now, the car is with me and I have it turned on and I have it pinging for every set 2 minutes on my location. So this is how it will look up on the dashboard for the location.
Okay, so this is our basic business plan. So our cost per unit is total, including labor and maintenance, is $152.88. And for selling, it'll cost $356.92. So net income per unit will be $204. So I just did the basic cost for 1,000 unit, and with that, our net income will be $151,707. This is just our basic business plan. So our potential future application of our system will be vehicle-to-vehicle communication, where it is the ability of vehicle to connect wirelessly and exchange information about the speed and position of the vehicles. This helps to avoid crashes and ease traffic congestion and improve the environment. The vehicle gesture control is ability of vehicle to understand gestures. For example, in a 4-lane street with narrows to 2 and the workers repairing a pothole, and one worker holds the stop sign with his left hand and wave cars to the right. So in this situation, the car would understand the stop sign and would likely to stop. And similarly, the people who are already handicapped, they can in the driving seat, they can also use hand gestures to control the direction of the car. The Internet of Things, where IoT can connect all types of devices to internet to share information and use the added value. So vehicles can be connected to share information from board sensor as well as smartphones of the pedestrians, cyclists. All these information are combined to help enhance data and provide added value to service to all the vehicles. Lastly, it could be we could also add the voice control system, where the autonomous car can use a voice command to control other car. For example, you can say something like, let me get I would like some coffee, and the car will take you to the nearest coffee place. Or you can also say something like, let's go to my favorite coffee place on Main Street. So different voice commands can create different trips, but ultimately user can control how much of freedom they can give to the car. That's pretty much it. Thank you.
Thanks so much. And any question for the PSY BOT?
Just a comment. In a professional setting, when you're giving a presentation, it's a good idea to have your video on. So none of you guys did that. So, especially if you go for job interviews or something, it doesn't look good if your video is off.
Thank you. Any other comment?
Sorry.
A quick question. How is your design better than what is out there in the market right now?
Any of you can answer?
So by design, what do you mean by design? By our demonstration of using a toy car?
Your features of your product.
So, well, we wanted to upscale this project to an actual car, but that would be too much of a risk. So we downscaled it to a toy car. Well, the intention was to like remote control your car. So it's like if you're in a tight parking space, but you don't want to get into the car and scratch someone else's car, you could just Bluetooth your car to like ease your way out and park in a different parking space so you could enter. So the installation of was more of the premise of our idea.
And also, I would like to add one more thing. Our real-time GPS location is accurate to 1 meter, so which means we can use it inside the malls and airports. That is also the one of the our where we can use it best.
Okay. Any other questions?
Thank you.
Okay, if there's no more question, thanks so much all of you, and congratulations. You did a great job throughout the 2 semester, and specifically the last couple of weeks. I believe that you spend a lot of time for the project, and sometimes fighting each other, but that's normal. But there is time to get along with the other, even though we are not in person the class. Thanks so much. And there's several the housekeeping job you guys need to do, but this is the required. And after the final presentation today, please submit any missing document, including the today's presentation file and the writing up by the April 26th. Then I'm going to ask your advisor to grade the full last 2 semester. And but the full year, the project writing up, please include the two the important thing. One is the project timeline, and another one is the business plan. I think that you already did for this one from the proposal, but this time you can revise if there is any change, and for the realistic the data, then you can put your the project timeline and the management issue and the business plan. There's the cost analysis and the target, the customer and the marketing and so on. Then the return your the project, the physical project with the working condition. Well, on April 28th, I'm going to be in my office, the engineer building, the Tech 156. You can bring the project to my office, or if you cannot access the building, you can email or send a message to the canvas. Then I can let you guys. I will pick up the item in front of the door, engineering building door, facing to the parking lot. Okay, so between 2 and 4 p.m. If you are not available, none of you are available, please contact me as soon as possible. Then we can set up the different time slot. Okay, then complete the exit survey one more time. I'm going to give the link for your reminder. So there are 2 exit survey. So one is for the senior exit survey, another one is a senior project survey. If you do not complete this one, even though officially this is anonymous, but Professor Abhilasha will check the email whether you submit or not. So the final grade will not be reported. Please complete this one. It will not take a long time. But there's one more thing. Professor Abhilasha to complete there is a checklist by the student, right? Could you
Sorry, there are a couple of things that we are requesting you to fill out. They are very easy forms. All you have to do is put in checklist. There is a list of constraints. Whether you considered as you were designing your projects, whether this was, this had to do with eco-friendliness, whether it had a social impact, whether, public health and safety. Just go through the list. It is just a series of check marks. Whether it was applicable or not is a different story. That you thought about it already has a checklist there. I can put a check mark if it was something you found applicable, put a check mark under that column also. And then we are requesting you to please put scores on teamwork, so you will be providing peer feedback. And again, it's just on a scale, a 1 to 5 scale basis, so it's not any extra write-up or anything that is required. And I thank half of you have already filled out the surveys, so again, a big thank you, and I'm sure the rest will follow soon.
Is it part of the exit survey, or is a separate document?
These are separate, Jonkyu. I sent you by email. I'll send it to you in PPT slide format, so it will be easy for them to fill out.
Ask the student to fill out.
Sure.
Okay. Thank you. Any last the comment, if there are any?
Yeah, I just wanted to congratulate all the students for doing, an excellent job on all the projects. It's really, I mean, you guys have been here, 3-4 years, and it's amazing, satisfying to see how much you guys have learned, how much you guys have matured, and what, great software, hardware you put together. And my sincerest appreciation to Professor Lee for keeping you guys on track and doing such a great job. So thank you, Professor Lee, for your amazing work.
Thanks so much. And I think pretty much that's it. And we have the small thing to finalize it. One more thing. right now, you are always welcome to the Wheelers Recreation Center to get vaccine. Even if you are lazy to make the appointment, they allow. But you should do something, the paperwork, such a thing. But go to the website and make an appointment. And next day that you can get vaccine. So please don't forget to get vaccine for your health. Thanks so much, and stay safe. And that's it. Thanks so much. Thank you, Professor Osif, Avlasha, and Damiat. Thanks so much.
Bye, everyone.
Thank you. Thank you, Jankyo.